All right, so we're going to wrap this chapter up by looking at some angles that show up on parallel lines. And first of all, a little vocabulary. This line right here has a special name. It's called a transversal. It's called a transversal because trans means across, and it's going across those two lines. And so when you take two lines and you cut them with a transversal, how many angles are created? 8. Okay, the 8 angles are paired up in fun ways. The first way is there's pairs that are called corresponding angles. And corresponding angles are angles that are in sort of the same location. So for example, if I said angle 1, what angle down here is in the same location as angle 1? Angle 5, because this is upper left, angle 5 is upper left. So angle 1 and angle 5 are corresponding angles. Which one from down there goes with angle 2? Angle 6, because this is upper right and this is upper right. So those are corresponding angles. Give me another pair of corresponding angles. Cameron? 3 and 7. So this is in the lower right and this is in the lower right. And then the last pair are 4 and 8. Okay? So those are all corresponding angles. Alright. Then we can break it down even further or come up with another sets of pairs. There are also ones that are called alternate interior angles. So the idea of interior means inside these two lines. So you know you're going to pick some angles from inside these two lines. And alternate means they're on opposite sides of this transversal. So for example, angle 4 and angle 6 are alternate interior angles. Since they're on opposite sides of this line, right? They're alternating sides and they're in between these two. What's my other pair of alternate interior angles? 3 and 5. And if we can have alternate interior angles, why would we not have alternate exterior angles? I don't know. So, can you give me a pair of alternate exterior angles? 7 and 1, good, because they're on alternating sides of the transversal and they are outside of these two lines. So angle 7 and angle 1, and what else? 2 and 8. Okay? So lots of pairs of angles that you can talk about. Alright? If you take the original two lines and magically make them parallel, something fun happens with all of those pairs of angles. And we're supposed to today do a little investigation where you're drawing parallel lines on padding paper and checking it all out from there, but we don't really have time. We'll just throw it up here on this board using my little cheating program. So I'm going to take a line and I'm going to make a line parallel to that. And then I'm going to draw a transversal. And I'll throw some random points out on these lines. Okay? So let's start with the corresponding angles. So if I measure this angle right here, and I measure this angle down here, what do you think is going to be true about the measure of that angle and the measure of that angle? They're going to be the same. And sure enough, that's what happens. Okay? So those two are called what? Corresponding angles. Good. All right. Now let's take a look at an alternate interior angle. So if I measure this one again, I I guess I have that one already. That's right. I'll put it down here. And then I measure the alternate interior angle that goes with it. What do you think is true about those? They are also the same. Okay? So these alternate interior angles, this one here, nope, just give up. All right, and that one there are also the same. There it is. And then I'm going to measure a pair of alternate exterior angles. So let's get a little different measure going here. Let's measure that one here. So this is that angle. Okay, you got that? And then I'm going to measure this angle over here. What's going to be true about those, do you think? Do you think they are also the same? Way wrong this time! Oh no, never mind. Okay, so those are the same also. So we came up with 3 pairs of angles, corresponding angles, alternate interior angles, alternate exterior angles, and it turns out that all of those angles are, pairs of angles are going to be congruent. And you can see that if I take one of those points and put it randomly in motion, they're going to remain congruent. Okay? So I did not trick you by drawing the drawing in a particular way. That will be the case no matter what my drawing looks like. Okay? And so that gives us this big honkin' conjecture. Which looks like that. So you might want to copy that down if you think you might have a hard time remembering it. Remember that this is in the case only where the 2 lines are parallel. Okay, so we have to start with the 2 lines being parallel. Then we know corresponding angles are congruent. Alternate interior angles are congruent. And the alternate exterior angles are congruent as well. And I will come back to this in one quick, brief second. Nope, this is only going to take a second.